moving on to the next section in our statistics and probability chapter. We're looking at sample space and margin of error. So some of this is probably going to be new to you. We're going to start with looking at sample proportions. So don't overthink this, but we want this sentence: out of 80 students, 21 have a black car. How would you write that as a sample proportion percent? What would you do? 21 divided by 80 and get what?
.2625. 2625.
Which is what percent?
26.
Okay, and typically they're wanting you to just round to the nearest whole number, sometimes to the nearest tenth. But that would be saying that about 26% of those students at that school have a black car. Now, margin of error. Wait till you get this definition written down. This is probably new to you. So when you collect data from a group of people, you're probably going to be figuring something out and then assuming that that same thing happens in the entire population. Now, because you're only looking at a small group of people and then putting that blanket statement over the whole population, there's going to be a margin of error. The larger amount of people or objects that you collect in your survey or questionnaire, whatever you're doing, the less error that you're going to have, because you're going to be covering more people. But if you just survey a small group of people, there's going to be a larger margin of error, because it's probably not going to be exactly what the whole population would say. So as you get more people, your margin of error goes down. So this example you don't need to write down, because we're going to do an example on the next page. But for instance, a poll reports that 35% of voters favor candidate B with a margin of error at plus or minus 3%. What that means is they took a poll, and of the group of people that they surveyed, 35% of them wanted candidate B. The size of the group of people resulted in a margin of error plus or minus 3%. So, in other words, written in blue here, anywhere between 32% and 38% are going to pick candidate B. Question.
If you get like a margin of error of like 3.164, do you round up to the whole number, or?
Margin of error, they usually round to the nearest tenth. At least we're going to for our purposes. So this is the example I want you to write down. It doesn't have a word problem to go along with it, but let's say our sample size was 500. We surveyed 500 people. The margin of error would end up being plus or minus 4%. And the way that I calculated that was 1 over the square root of whatever your population size is. So it's not a formula, I'm just showing you an example, and we're going to follow that same example for the question written in red.
I'm trying to learn too.
So the question in red, once you get that written down, is asking us to work backwards. They give us the margin of error and they want to know what population size we started with. So we have to figure out how to set that up and how to solve it. So the margin of error that they're talking about is 6.5%. We don't know the population size. So that's where our x is going to go. We don't know how big the group was. But we do know that it ended up being plus or minus 6.5%. Now, when you put that into your calculator, how should you write that? So this as a decimal, and I'm going to ignore the plus or minus because it's on both sides. So really this is our equation and we're trying to figure out what x was. What did the sample size start out as? So what could we do to both sides? What should we do? Okay, we can do that. Now we have this. What would be best at this point? One more time. And the last step. Square both sides. Make sure you're not timesing it by 2, but you're actually raising it to the second power. And these are objects or people that we were collecting, so make sure there's not a decimal after it. Round it to the nearest whole number. 237 was your initial population. Bias. This is what we're going to talk about on the next page. This I do want you to write down because the next 3 examples we're just going to talk about and not have you write down unless you have the notes printed out. So this is the one thing you do need to have. Bias is where one outcome is more likely than another. For instance, I have a bias towards my daughter if you asked me if my daughter is cuter or the neighbor's daughter is cuter. I'm going to pick my kid because I have a bias towards her. So whenever you're doing a survey, you want to make sure that it's unbiased so that you're getting good data. So I'm going to give you 3 examples on the next page, and we're going to figure out are they biased or unbiased. Here's the first one. Viewers of the Heavy Metal Music Awards are asked to call in and name their favorite artist. Why?
Because the heavy metal music awards, they might say like heavy metal people are their favorite artists instead of their favorite artists.
Correct. The other genres of music aren't going to be represented at all because it's only the people watching that award show, so they probably like that music, and they're probably not going to say country artists or classical or something else. Okay, we'll check that in a moment. A magazine asks its readers to fill out and send in a questionnaire. Okay, how come?
Because it's not the same.
Okay, so that one we're saying unbiased, and this one? School newspaper interviews 20 random students about homecoming. Unbiased, how come? Because it's random, that definitely says that. One of them that you said was incorrect. Let's find out. The middle one is actually biased. If you're truly wanting a questionnaire filled out, that magazine could be like a car magazine, for instance, and then it's only people who read car magazines that are answering that questionnaire. So it has to be completely random in order to have it be unbiased. So on the homework, they're going to ask you if it is biased, how could you fix it? So this is examples of how you could fix it. I'm not asking you to write it down, but just kind of keep it in mind when you're doing that homework section on the worksheet today. Questions on bias before the last slide? All right, so we're going to look at margin of error one more time in this case. So if you don't have the notes printed out, here's what you need to write down. Yep, I have 7 class periods, so it happens a lot. All right, so calculator is dropped on the ground 360 times in a school year. Of those times, 96 caused damage to the calculator. Now, these aren't actual statistics, but they are approximated. And 96 is way over-exaggerated. But for the purpose of this example, we're going to use those 2 numbers. So what's underlined is the important information that you need in order to answer the following questions. We need the sample proportion. How are we going to find the sample proportion? We did this on the beginning of the notes. What would we do? Our first example is about black cars. Yes. Let's write it as a percent. What would that be? 27%? Let's do 1 decimal after. Did that run it correctly? Okay. All right, so that's the sample proportion. So 26% of the calculators got damaged when they were dropped. The margin of error, how do we find that? Something with a fraction. 1 over the square root of, it's not x, it is a number. Which one would you use? The total sample, which is 360 times. So what is the margin of error? So what is that as a percent? That you just found this. I need to know this. You found this answer? Did you divide those two? Because that's the answer you just gave me. It was 0.267. I want to know this. What is it? So what is that? 5%? 5 point what? Okay, so that means that the margin of error is going to be 5.3% in either direction of that answer. So that gives us a range. So what is the interval that's likely to contain the true population of all classrooms when calculators are dropped 360 times? What would the range be? How are we going to do this? Subtract and add your 5.3. So what's the range going to end up being? $21.4? So somewhere in that range is where all other classrooms would fall if we were looking at the entire population. Because we just took a tiny little sample, just this classroom. Questions on anything? Let's check our answers, make sure we got them right. We're good. We should have a plus or minus on it. Questions? 5.3, by putting this into your calculator, 1 divided by the square root of 360. The interval, we took 26.7 plus 5.3 and 26.7 minus 5.3. Because the margin of error tells us how far in each direction the true answer is going to fall in between those two. Alrighty.